Hey guys, today we're starting a new unit and we're learning about acids and bases in this unit. Today will just be a quick cover, basically, of what we can expect to learn from this unit. An introduction, that's what I meant to say. An introduction to what acids and bases actually even are. So first, we're going to watch this video. Before we get started, we're going to watch this quick video here. And we're going to think about the question, before we start, which substance do you think will be more damaging to the aluminum Coke can, the acid or the base? So take about 2 minutes and think about that. Ask yourself which one you think would cause the most damage to an aluminum Coca-Cola can. Okay, we'll go ahead and watch this video and see what happens. Great. So was anybody surprised by what happened with the Coke can? Were we expecting the acid to do more damage to the Coke can than the base did? Is the question that we're asking here. It shouldn't surprise you to learn that acids and bases can both be equally damaging in the right amount, in the right quantity. And that's something that we're going to explore more as we get more information about acids and bases. So, first things first, what is an acid? An acid is any typically liquid with a pH balance of less than 7. 7 or, well, yeah, less than 7. They are typically sour tasting and they act as preservatives to help keep food good longer. They do this by killing microorganisms that make food go bad. Acids are very reactive, which means they are explosive, and corrosive, which means that they can eat away at things. And so we should handle them with care. Some acids that you might be familiar with are like sour cream, pop, or soda, and then vinegar over here. Can you think of some other things that might qualify as an acid that you use on a regular basis? Great. Those are some great suggestions. So we're going to go ahead and learn a little bit more. Acids also conduct electricity. So they are covalent compounds, which means that they are two or more nonmetals that have bonded together. When they're placed in water, they collide with the water molecules, and that breaks the acids up into ions. Those ions are used to conduct electricity. Okay. Some examples of acids that we see regularly are again vinegar, are citric acids, which you can find in our citrus fruits like lemons and limes, oranges and grapes, oranges and grapefruit. Lactic acid you can find in some foods, such as pickled vegetables. If you like sourdough bread, then you might find it in sourdough. You can also find it in soy sauce, and then also like yogurt or other fermented dairy products would have lactic acid in them. These are just some examples of common acids that we might see and their uses. So, for example, here we have hydrofluoric acid, which we can use to etch glass. So, if you have stained glass, this is what's used to help create the paintings and portraits inside of it, and hydrochloric acid, which they use to clean concrete, and then acetic acid, which you should be very familiar with because acetic acid is just another name for vinegar. So, this is something that you probably have some experience with. And then nitric acid is a yellowish acid that is typically used for like sanitizing. That's maybe when you might have come in contact with it, although I doubt that you have. We also see acids in our everyday lives because acid is excreted by the stomach lining. Hydrochloric acid, specifically, is what helps to break down the food that we eat by weakening the bonds, and it also dissolves minerals from various foods. It also works to help us fight off bacteria by killing bacteria which enters our stomach with the food that we eat. We might also see it in acid rain. As you guys know, we create fuel by burning fossils or dead organisms, which have been buried underground for millions of years. When we burn fossil fuels like coal and oil and gas to make energy, they release they release nutrients which form undesirable compounds. Okay, they do that by releasing nitrogen and sulfur into the air, and that combines with oxygen and water to form acid. And then that acid falls to earth as acid precipitation in the form of typically rain, but it can also fall in sleet or snow. This can cause forests to lose valuable nutrients, which could kill the plant life. It can cause problems in your aquatic ecosystems by killing fish and amphibians and other organisms because of a decrease in the pH of the water they live in. And it can also destroy stonework, like you see here. Aces, on the other hand, have a pH of greater than 7. They also have a bitter taste, and they are also reactive, meaning corrosive, meaning that they eat away at material. So they too are dangerous in the proper amounts. Examples of bases include drain cleaner, like this Dranomax here, some soaps, and antacids, like the Tums that you might take if you have an upset stomach. Most bases are ionic compounds. This means that they are a metal and a nonmetal, or at least one metal and one nonmetal, combined together. And so they too will dissolve in water to form ions, which means that bases can also conduct electricity. Some common bases that you might see are sodium hydroxide, which is used to make paper, and calcium hydroxide, which helps decrease acidity in lakes and soil to make it easier for wildlife to live in lakes, and also for reforestation, which is the process of regrowing a forest that has been um, terminated. So that is the end of this particular introductory lesson. I told you it wasn't going to take too long. We are all set on this one. See you guys next time.